All right. Good morning. Happy Monday. Okay, so yesterday, um, with all the emails I had for the exam and all the remind messages, I started at 5 a.m. and I finished at 5 p.m. Because I wanted to watch the Dodger games. So, um, yeah, 12 hours of sending messages, looking at late, going to classroom, going back to Pearson, the My Math Lab, looking at exam scores, yeah, it's just crazy. So I just want to say a couple things. First of all, I'm not taking late assignments. So I'm not going to send any messages. You're just getting it as zero. So unless there's an extenuating circumstance where you have set up a meeting with me, no late work. Also late scratch paper, not going to take it. So I had two students. One student got a 96 and the other student got an 82 and didn't turn in their scratch paper. I was trying to hunt them down. I was trying to get them to call me. I'm not doing that in the future. So it's taking up my entire life. I'm not going to do it. So yesterday was that was the final straw. So you must turn in your assignments on time, pay attention to deadlines. You must turn in your percentage. Some people are just turning in the assignment without the percentage. There's all kinds of stuff going on. So all I know is it's wasting my time and I'm done with it. You have to be responsible. Okay, we've been doing this since August. I expect your assignments to be turned in and I expect your scratch paper. You can't turn in your scratch paper 20 minutes later so you can change your scratch paper to match, exam answers. I'm not going to do that. So I'm letting you know. If you don't want a zero, turn your stuff in on time. Also, I can see the difference in people that are using the online ebook and the globes and practicing. The people who are using the e-text and practicing the problems online before the test, they know how to input the answers. They know how to write things. And those people are getting A's and B's. Some people are getting 100%. Other people doing all kinds of weird stuff because you're not practicing the problems online. So you got to work the globe problems online if you want to get the answers right. For example, on the last exam, they said to write your answers in interval notation. Some of you wrote your answers in inequality notation. You would have known that if you had done the online problem. So I'm not going to give you credit for that type of stuff. You're responsible for doing the globe problems to study for the test, and you are responsible for knowing how to put the problems in the test. The exams are grading correctly from what I can tell. It's my students that are not inputting things correctly. So I'm just letting you know. Please don't have me grade things that it is grading correctly. So unless you know for sure something's incorrect, don't have me go through and grade a test. Took me 12 hours on Sunday to go through and grade things that you did incorrectly. All right, today I'm going to be talking about lesson 1, 2, and I'm only going to teach half a lesson. We're going to work in the Math Wizard teams, and I'm going to give you a warning about this one too. You are to work together in the Math Wizard teams the way I have specified. If you do not, we're not going to do the Math Wizard teams anymore, and I'm just going to teach. So every single day we meet, I'm going to be teaching. So the reason why I'm doing the Math Wizard teams is so you can check for understanding, work with your team, and get problems resolved. If you're not going to work with your team, we're not going to do it. So I'm just letting you know. Period 1 set me off with what they were doing. And so I'm just letting you know, if you want to work in the Math Wizard teams, you must work together. And if not, we will not have them anymore. All right, can you guys open up your books to page 176? We're looking at functions and their graphs. Okay, let's look at problems on page 176, 1 through 10. I'm going to talk about 4 things in problems 1 through 10. I'm going to talk about a relation, a function, and domain and range. So let's take a look at the definition of a function. Okay, a function looks like f of x. This is a special notation, and it's read as f of x. So f in terms of x. So this thing stands for y. So the question is, why don't we just call it y? Because he's special, and he wants to be called f of x. So even though he is a y, he wants to be called f of x. So kind of like, you know, you don't call me out of respect. You don't call me Roxanne. Only my friends and family call me Roxanne. As my students, as a sign of respect for me, you call me Miss Birch or Birch, whatever. Maybe even call me worse names than that. But anyhow, out of respect, the function wants to be called f of x, not y. Okay? So with that, what does a function look like? Well, a parabola is a function. And the reason why is if you hold your pencil up vertically, if it only passes through your pencil once, it's a function. Now, a line that has slope, it passes the vertical line test, it is a function. The only line that's not a function is a vertical line because it fails the vertical line test. Now, the sine curve in trigonometry that looks like this, it passes the vertical line test. So what would not be a function? Well, let's look at something that's not a function. A circle, not a function. Because if you hold vertically, it crosses my pencil twice, and that's the vertical line test. Got a squiggle like this. That's not a function. You guys see that? My board's wet. That's not a function. Because if you hold your pencil vertically, it crosses through my pencil like 4 times. That's not a function. Okay, now let's say you don't have a graph. If you don't have a graph, your x's repeat. Ugh. Yeah, my board's completely wet. I don't know why. So for example, this is called a relation. It's just a set of ordered pairs. So a relation is just a set of ordered pairs. So the question is it a function? Well, you see these ones right here? The ones can't repeat. So this is not a function. And if somebody asks, well, why is it a function? You would say because the x's repeat. In other words, these, write one down 3 is there, and write one down 4. See how it fails the vertical line test? So the x repeat. It doesn't matter that the y's repeat. It's just the x's. Is a special notation. X's can't repeat and it has to pass the vertical line test. A relation is just a set of ordered pairs, and we're looking at domain. Now, the domain are just the x values, or graph exists left and right. The range are the y values. So if I asked you what's the domain, you would just give me the x values. So what are the x values? 1, 1, and 2, right? So in a set, you can repeat elements, so just write them once. I'm going to write 1, 1, 1, 1, 1. I'm just going to write 1 and 2 is the domain. And even repeated, we can element set. The range is -3, -4. So those are the answers to the problem. We're going to do it. So let's do problem number 2. This is on page 176. So we have a relation 4, 5, 6, 7, 8, 8. So that's just a relation, a set of order, big deal. So they want to know, is this a function? Okay, well, unmute yourself and tell me, is this a function or not?
Yes.
Why?
Because they're all different x values.
Right, exactly. They said, why is it? They're all different x values. Good, perfect. All right, what's the domain? Go ahead and let's see. What's the domain?
4, 6, 8.
4, 6, and 8. Good. What's the range?
5.
Uh,
Go ahead and let's see.
5, 7, and 8.
Easy, right? So y'all gonna get 100% on this? So a relation is a set of ordered pairs. A function passes the vertical line test. Like you said, the x's don't repeat. The domain are the x coordinates. The range are the y coordinates, and that's it. Does anybody have any questions about problems 1 through 10? So this is a new stuff, right? You have this like in pre-algebra, algebra 1. Hopefully. I don't know what they're doing these days in those classes. It stresses me out. I should say you should have had that in algebra 1. Okay, let's look at problems 11 through 26. They want to know if y of x so let's take a look at problem number 12. Just solve for y, guys. Solve for y. And they want to know, does it pass the vertical line test? So in the first one, you have x plus y equals 20. So when you solve for y, wouldn't this be negative x plus 25? So you should recognize this. What is this? Is this a cubic, a square? What is this thing? Is it a quadratic? What is it? It has an x. What is it?
Straight line.
It's a straight line. And so you know about lines. They pass the line test. And another way to write this would be y of x. So y in terms of x. And that's what they're wanting to know. Is that a function? And yes, it is. Number 14. X squared plus y equals 25. When you solve for y, don't you get this? Well, you know what that is. We just did like 20, 40 problems with this. What is it? This is not y of x, it's f of x.
A U shape.
Yeah, f of x, right? Y is f of x. Remember we talked about that? Y is f of x, not y of x, f of x. So this is a quadratic. Well, a quadratic passes the vertical line test. So yes, this is a function. So let's try a harder one, 16. We haven't seen that. So solve for y. Take the square root of both sides, put plus or minus. Now, you may not know how to graph that, but this is two graphs. The positive square root looks like this, and the negative square root looks like that, and that's a circle. Now, if you just had one, you could put it on the calculator. Square root of that and graph it, negative square root of that, if you don't know how to graph it by hand. If you just had one of them, it would be a function because it would be square root. But since you have two, it creates a circle. So this is not a function. This is not a function. It's going to fail the vertical line test. So it can't be written like f of x. It can't be written in like y. It's not a function. All right, so for those problems, just solve for y. You can either just look at them and say, yes, because it's a line, yes, because it's a quadratic, no, and you can put it on the calculator if you want and say, no, it's not a function because it's a circle and it fails the vertical line test. So, yeah. Now, you know about like 12 functions. Remember I gave you the parent sheet? So you know that the line is a function, you know the quadratic is a function, you know the cubic is a function, you know the absolute value is a b, it's a function, square root is a function, exponential graphs are functions, logarithmic functions. There's a whole page of them that I gave you as the parents. All right, let's go to problem number 20. The problem's 27 on, and we'll do 28. Okay, 28 is g of x is equal to, I'm going to do 30 instead. 30 is harder. G of x is equal to x squared minus 3. That's the function because it's g of x. And they say in A, evaluate g of -1. So here's what you're going to do. Wherever you see an x, you're going to put -1. So you're going to take the x's out and put in -1. So this would be g of -1 is equal to -1 quantity squared minus 10 times -1 minus 3. So if you notice, wherever there was an x, I took it out and I put -1 in, and this is we're evaluating. Now, when you do this problem, a -1 quantity squared is a +1. Negative times a negative is a positive, minus 3 is 11 minus 3, which is what, 8? So in other words, this is a fancy way of writing an ordered pair. When x is -1, y is 8. When x is -1, y is 8, and g of -1 is the y value. It's a special notation. So I'll say it again. X is -1, y is 8, and g of -1 is a label. which means y. B, they want us g of x plus 2. So now we're going to take out the x and put x plus. So wherever you see an x, you're going to put x plus 2. Wherever you see an x, you're going to put x plus 2 minus 3. So this problem's a lot harder. So see how I took the x out, x plus 2 everywhere. So I picked a fun problem. So this is a FOIL. This is distributing negative 10x minus 20 minus 3. This is first, outer, inner, last, minus 10x. So I'm just going to add that to 23. Combine like terms. You get x squared plus 4x. You put these together. I'll do it in a minute. Lovely problem. So this is x squared. A positive is negative, and a positive and negative is a negative 19. Turn the back. This is lesson 1-2. Lesson 1-2, number 30B. Okay, 1-2, 30B. X squared plus 10x minus 3. I'm sorry, x squared minus 6x minus 19. This is right. So when x is x plus 2, y is x squared minus 6x minus 19, and this is the y value, g of x plus 2. So you're not going to have anything that hard on a test, but I just wanted to show you how to do it. Okay, so let's do C. So in C, it's g of negative x. So wherever you see an x, you put a negative x. So this should be g of negative x. This would be negative x quantity squared minus 10 times negative x minus 3. So this would be a positive x squared plus 10x minus 3 is your answer. Okay, anybody want to add, if this is evaluating? So anybody want to know how to evaluate a function? All right. So remember we did transformations? So we did the transformations. The 39 through 54. So I'm just going to review this real quick. If you have a line, you're going to use slope intercept form, and I'll show you that in a minute. If you have a parent that's a quadratic, you know what that looks like, and you're going to use these points, left one, up one, 0, 0, right one, up one. All right, now they're going to throw in absolute value. So absolute value looks like a V, and the points you're going to use are the same. Left one, up one, 0, 0, right one, up one. They're also going to throw in the parent of square root. Well, square root, if you look on that paper, goes off to the right. And the points you're going to use are square root of 0 is 0. And if you put in a 1, the square root of 1 is 1. So you're just going to use 2 points and go off to the right. The only other one is the cubic. That's the parent, and it looks like a snake. If you put in a -1 quantity cube is -1, so it's not left 1 up 1, it's left 1 down 1. If you put in a 0, you get a 0. And if you put in a 1, 1 cubed is 1. So those are the parent points. So if you know how to do transformations, you're going to just know the points for the parents, and you're going to graph them. So let's go through this. Problems 39 through 42 are lines, and I'm going to show you we're going to do slope intercept form. We're not going to use transformations because it's dumb to do that. All right, number 43, unmute yourself and tell me. What does G do to the parent? State the transformation. (43) is a quadratic. What's the transformation? Come on, we did like 40 problems like this. That's why we did it. Go ahead, I'm waiting. Number 43, state the transformation. What does G do to the F? Are you guys out there? Hello?
Yeah, we're here. I don't know.
Doesn't G move the parent up 1? Didn't we go over A, B, H, and K? Didn't we state the transformation, show the transformational points and graph? So doesn't 43 move the parent up 1? Okay, what about 44? What does G do to the parent?
It goes down 2.
Right. Number 45, that's absolute value. That's a V. What does he do to the parent, G? Moves the parent down what?
Down 2.
Down 2.
46. What does G do to the parent of absolute value?
Up 1.
Right. 47 is a cubic. It looks like a snake. What does G do to the parent F?
Up 2.
Right. 48. What does G do to the parent of the cubic? Down 1, right?
Mm-hmm.
So in all these problems, you're not even doing vertical stretches or compressions, or what all you're doing is taking a graph up, down, left, right. So you can show the transformational points, but you don't even need to. Just move the points right, left, up, or down. And if you don't know what I'm talking about, you're going to have to make a table, which is going to suck up like 5 hours. Okay, look at 51. They want you to make a table. We're not going to do that. So F is square root of X. What does G do to the parent of square root? So here's square root. What does G do to the parent?
Goes down 1.
Moves it down 1. 52. What does G do to the parent?
Up 2.
Right. 53. What does G do to the parent? It's in the radical, right? In
Right
the
one.
square, in the cube, in the radical, right 1. What is 54? What does G do to the parent?
Left 2.
Right. Okay, so now that we got that, now we know what we're doing. Let me do some problems. So let me do number 40 as a line. We're not going to use transformations on a line. We're going to use algebra 1. So that it's a line. Why is it a line? It's x to the 1. And g of x is x minus 4. Don't use transformations. So we're going to use, remember, slope intercept form. So in this one, M is 1, so it'd be 1 over 1, or down 1, left 1, up 1, right 1, up 1, right 1, or down 1, left 1. We went over prerequisites. It's plus 0, so the intercept is 0. Over here, the slope, up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1, and the intercept is 0, down 4. So now you're going to graph both of them. So 0, 0, you're going to go up 1, right 1, up 1, right 1, or you could go down 1, left 1 and draw the graph. On the other one, I'm going to do it in a different color, and you can too. Going to go 0, down 4. The slope is up 1, right 1, up 1, right 1, up 1, right 1. Draw the graph. And of course, they're parallel because they have the same slope. Let's do number 46, absolute value. They're saying the parent is the absolute value of x. And they're saying for g of x, it's the absolute value of x plus 1. Well, absolute value looks like a V, and the points, remember, are left 1, up 1, 0, 0, right 1, up 1. If you can't remember it, just plug them into the parent. So we can graph the parent right away. The parent is left 1, up 1, 0, 0, right 1, up 1, and draw a V. As for G, you're moving it up 1. Can't you just move the points up 1? So can't you go up 1, up 1, up 1, and draw the graph? Of course you can. If that doesn't make sense, you can take the parent points and do what we did in that assignment. Up 1 means leave the x alone and move the y up 1, up 1, up 1, and there you go. Left 1, up 2, 0, up 1, right 1, up 2. There's your graph. Now, this is going to get harder in future chapters, but right now, we're not even changing the graph. We're just moving it up, right, down, or left. We're just doing translations. We're not doing any transformations. That's why I went over this, so that you could just easily graph them and not make a table. Like I said, with lines, we're going to use slope-intercept form. These lines are pretty simple. F of x is the identity. You're just moving it down 4. So it's pretty simple, but the lines, as they get harder, it's easier to use slope-intercept form. Okay, any questions about graphing a line or absolute value? I'm going to do square root right now in problem number 52. But this is why we did transformation, so you could graph these quickly. All right, let's do square root 52, and then we're going to go into the teams and practice. Okay, they're saying the parent is square root of x. So the points are, if you put in a 0, square root is 0 is 0. If you put in a 1, the square root of 1 is 1. So you're just using those 2 points. So we can graph square root right now. You have to know what it looks like, though. Has to go off to the right. So 0, 0, right 1, up 1. And you know square root goes off to the right. So G, that means move the parent up 2. And in this, they're writing a whole bunch of stuff and they're wanting you to make a table. We're not doing that. Just move it up 2. So move this up 2 and move him up 2 and draw the graph. And like I said, if that bothers you, you can take 0, 0, right 1, up 1, and move the y up 2. Move the y up 2, and there you go. 0 up 2, right 1 up 3. So whatever you want to do. So they're asking you, what is G doing to the parent? So you would write, G is moving the parent up 2. This is the parent. G is moving the parent up 2. Over here, G is moving the parent up 1. So we're not making a table. Right? In the last assignment, the transformation, we stated the transformation. We showed the transformational points, and we're going up 2. Now, this is way easier than what I gave you because we're not quite there yet with what I gave you. So this is just simple translations. But you have to know what the graphs look like. You have to know that absolute value looks like a V. You need to know the square root goes off to the right. You can look at your parent list. I gave you a list of parents. All right. Well, it's 11:30. Class is over at 12:10. So here's what we're going to do. You're going to go into your Math Wizard teams until 12 o'clock. You are going to come back to WebEx at 12. So the goal is to work these problems as a team that I'm going to put on the board. So last period, some people only worked 2 problems because they weren't working together. Other people finished this. Just depends what you do. So what I want you to do is you're going to do problems 1 and 3. Write it down. You're going to do problems 11 and 13. You're going to do problems 27 and 29. You're going to do problems 39, 41, and 51. 9 problems in a half an hour. So I want you to work together, please. 1, 3, 11, 13, 27, 29, 39, 41, 51, and then at 12 we'll come back if you have questions. So we're using these to check for understanding of what I just taught. All right? Okay, I'll see you in the Math Wizard teams. I'll be taking attendance in there too. You're going to report back to WebEx at 12. All right, I'll see you in there. Do y'all have this written down? All right, I'll see you in the teams. All right. Did you guys make it back?
Yeah.
Yep.
Yeah.
All right, I'll be honest, I'm just really frustrated today. I don't know, maybe it's just a bad day, but nobody's wanting to do what I want. And let me just remind you, okay, you guys, I've been teaching for 30 years. I've been teaching for double your age. All right. So have a little bit of respect for me, okay? I know what works with students, and I know what doesn't work with students, okay? I'm a master teacher. I teach teachers how to teach, okay? I've been around the block a few times with students, so I need you guys to do what I'm asking you to do, okay? All I know is math. I don't know history. I don't know English. I don't know Spanish. I don't know anything but math, okay? So when I work with you in the Math Wizard teams, I want you to do what I'm telling you to do, okay? I don't feel like you have the right to do what you want because you don't have the experience I have. So at least give me credit, for trying to do something with you. And if your grade is not that good, I would try to listen to me so that I can help you make your grade better. But if you don't listen to me and you think your way is always the best, then I can't help you. It's like me talking to the wall, nothing's going to happen. And that's how I feel with some of you. I feel like you just think you know everything and I don't know anything and I can't help you at all. And so you're just going to do it your way because that's the way you do it best. Well, if you're getting a C or a D or an F, that's not really that great, right? So shouldn't you at least try what I'm doing? Like give it a try? So when I work problems on the board, it's not my style, okay? It's the way you do math. And it's very important that you emulate what I'm doing. So whatever I write, you should be writing. When you're in the Math Wizard teams, I don't want you to work the problems separately and then check your answers. You weren't able to finish all the problems. Some of you were only on the second or third problem because you're doing it that way. I want to do all those problems in half an hour. So you should be able to do 8 problems in 30 minutes. So I want you to learn how to work together because 2 heads are better than 1. I don't want you working separately. Yes, Miss Birch, but that's how we do it best. I don't think so. So check out your grades and then get back to me on that. Okay, it's the A students, it's the A and B students that are actually talking, collaborating, and working together. So trust me, I look at these with Math Wizard, I have 5 classes, I'm looking at them every day. So please, okay? I'm trying to help you, but you have to try to do what I'm asking you to do. All right, now, who has questions about problems?
Number 51.
Okay, 51, the parent is square root. Now you have to know what that looks like. So look on the list that I gave you. Goes off to the right. And then it says that g of x is equal to the square root of x minus 1. So you should know what that means. So outside is k, and that means down 1. So we're not going to make a table. We're going to do the F graph. So if you put in a 0, you get a 0. If you put in a 1, the square root of 1 is 1. And we know that square root goes off to the right. So that's the F function without making a table. Now, this is saying G is moving the parent down 1. So you don't need to make a table. Just move that point down 1 and move that point down 1 and draw the graph. So that's it. So that's what I'm teaching. I'm not teaching algebra 1. Okay? So they're asking you, well, what does G do to the graph? You would say G of x moves F of x down 1. That's it. Do you understand what I'm doing?
Yeah.
So when we did those problems with the quadratic, we're just transferring it to the square root function, to the cubic function, to the cube root function, to the absolute value function. We're just doing the same thing with a different graph. That's it. So anything inside is A and H. Anything out, I'm sorry, B and H. Anything outside is A and K. But we're not going to see the transformations until later. These are just left, right, up, and down. These are easy. These are just easy problems, not as hard as what I gave you in that transformation assignment. But if some of you didn't do the assignment, so you can't do this. So that's why I stopped and I taught the transformations. Maybe you better watch my video if you weren't in class. So you can do this. So if you're in class, you know what I'm talking about. We stated the transformation, we showed the transformational points, and we graphed. If you miss class, you might want to watch the video. Otherwise, make a table and spend 3 hours doing the assignment rather than 1 second. Okay, go ahead. I have time for one or two more problems. Go ahead. Anybody still confused about 27, 29, 31? Or any of the graphing? All right, well, the other day, students were telling me about distance learning. They were saying they missed their friends at school. Some were saying that I hated school, now I want to go back to school. Some people were saying the teachers are giving too much work. So I just want you to know that I assign 40 problems, and that's 10 problems a day. The assignment's due on Thursday night. So I've listened to you, and I'm watching the amount of work. So I'm assigning 10 problems per day on this assignment, 1, 2. So there's no excuse for not doing the assignment, and there's no excuse for not doing well on the exam. Okay, I'm not assigning 1 through 1,000,000. I was real careful about how I made the assignment. So make sure you look in Google Classroom on that. Okay, last call. Anybody want to ask me any questions about anything before we leave? All right. Well, I expect a lot out of you. So I'm hoping that you'll rise to the expectation. Okay. I don't want you to stay down here in this rut. I mean, I want you to rise to the level that I expect you to rise to, but you must follow the leader. Have you ever heard the saying, too many cooks spoil the broth? That means too many leaders are messing things up. So I'm the leader. You're the student. We have to know our roles. Okay, I'm capable of leading, but you have to let me lead. You can't take over and start leading and think you know it. We have to have a leader that leads, and the students understand their role and follow the leader. Right? All right. You guys have a good day. And I will see you next time. Make sure you do the assignment. You should be able to do 1 through 54, the problems I assigned for them. I taught that today, so you should be able to do it. All right. Have a good day.